The last topic in mechanics is vectors. Now, we are going to consider these our two axes. Every point or every vector is going to be located by, say, this is a vector. This vector A is, we say, xy. We are going to say that a unit vector in the direction of the x-axis is called I. A unit vector in direction of the y-axis is going to be called j. And therefore, this vector A is going to be called xi plus yj. Working with I and j makes it easier to work with vectors, because when we add two vectors, a plus a and b, rather than adding them by drawing, we can add them by expressing them in terms of a, I, and j. For example, if we are given the vector p is 2i plus 3j, and the vector q is 5i plus j. What is p plus q? Very simply, we add the i's together, we say 7i, plus the j's together, 4j. And therefore, working with I and j makes life much easier. And one more thing is, whenever you want to get the magnitude of a vector, and if I say to you, what is its magnitude? What's the magnitude of this? Its magnitude, we say the square root of 7 squared plus 4 squared, and that's all. If, for example, we have a vector A is 5i plus 2j, and a vector B is 3i minus 4j, and want to find 2a minus b, we just multiply vector A times 2, 2 times 5i plus 2j, minus vector B 3i minus 4j. 2 times 5 is 10, 10 minus 3 is 7i. 2 times 2 is 4j, minus minus plus 4j, we get 8j. And this is the vector 2a minus b. Therefore, very simply, we can work with vectors in terms of I and j. And if we want to get the magnitude of any vector, we just get what is its magnitude. Its magnitude, we say the square root of 7 squared plus 8 squared. One thing is, when we wanted to find the direction of a vector, we must draw the vector. And if I say to you, what is the direction, right? For example, we say, what is the direction of vectors? For example, number A is 4i plus 5j, and then another one B, which is right is 3i minus 3 right root 3j. To get direction of any vector, you must draw the vector. Draw it. Now the vector 4i plus 5j means it is the x is positive and the y is positive, therefore the vector is here. This is 4 and this is 5. Therefore this is a vector. Now we are going to get this angle theta first. Right. Now we say this is the angle theta. We say tan theta equal to 5/4. Right. Now we get the angle theta is equal to الو انا عايز جون ازيك لا فيش مشكلة اوكي يا اهلا بيك النهارده اخر يوم من غير حظ تجول ايوه اوكي طيب يلا اوكي للقاء tan theta equal 5/4. We got the angle theta equal to, right, 51.3 degrees. If you were asked what is the bearing of that direction, we just say 90 minus 51.3. Okay, we got the bearing. It's going to be 36.9 degrees, because this is the bearing. This vector is 3i minus down there. This is 3i, and this is 3 root 3j. Now this is a vector. Now, we get this angle first, we draw it, and we have to draw the vector. So now we know that the vector is in the fourth quad. Right. Now, here is x positive and y negative. This angle theta, its tan theta is 3 root 3 over 3, which you get angle theta is 60 degrees. Therefore, if we ask what is the bearing, we say 90 plus 60, 150 degrees. Now, this is working simply with vectors. But we got now some very, say, advanced questions about vectors. Now, of course, getting the magnitude have no problem. If I want to get the magnitude of a vector, I just say the square root of the x bar squared plus the y squared. And then also to get the angles or direction of vectors is very easy, we draw it. But now we have very interesting question, like what? Like question saying we have vector A is 2i plus 5j, and we vector B is 3i minus j. Right. We have A plus lambda B is parallel to I. Find lambda. A plus lambda B equal to I. A plus lambda b, we say 2i plus 5g plus lambda times 3i minus g. This would be 2 plus 3 lambda I plus 5 minus lambda g. If this vector is parallel to I, means it does not contain g. It does not contain g, because a vector parallel to I will not contain g. This means 5 minus lambda equals 0, يبقى lambda equals 5. When a vector parallel to I, the vector would not contain g, and vice versa, like in the next example. We are given with this question. We are given again now the same thing. We are given the same vector A is 2i plus 5g and the vector B is 3i minus g, and we need mu A plus B parallel to G. Find mu. Mu A plus B would be mu times 2i plus 5g plus 3i minus g. We collect the i's together. 2 mu plus 3i plus 5 mu minus 1g. It says here that this vector is parallel to G, but does not have I. But I part to 0, but 2 mu plus 3 equals 0. Therefore, get the value of mu equal negative 3 over 2. Right. There's more interesting questions. This question. Well, given the vector C is 3i plus 4g, and the vector D is I minus 2g, and we need the vector C, mu C plus D to be parallel to I plus 3g. Mu C plus D equal mu times 3i plus 4g plus I minus 2g equal 3 mu plus 1i plus 4 mu minus 2g. Every vector has a direction. A direction, we can say, it's a gradient. The gradient of the vector is the j part of the I part. Therefore, this vector and the vector I plus 3j, they are parallel, but they have the same gradient. What is the gradient of I plus 3j? Equals 3 over 1. And the gradient of mu C plus D equal 4 mu minus 2 over 3 mu plus 1. We equate them. 4 mu minus 2 over 3 mu plus 1 is the same as 3 over 1. Cross multiplication, we got 9 mu plus 3 equal 4 mu minus 2. Therefore, we get 5 mu equal negative 5. Therefore, mu equal negative 1. Another question of the same kind. If we have again the same vectors, C is 3i plus 4j and D equal I minus 2j. And we are asked that the vector D minus TC is parallel to negative 2i plus 3j. D minus TC equal I minus 2j minus T 3i plus 4j. This is equal to 1 minus 3ti plus negative 2 negative 4tj. The gradient of minus 2i plus 3j is 3 over negative 2, and the gradient of D minus TC is negative 2 negative 4t over 1 minus 3t. We equate them. يبقى negative أو 3 over negative 2 equal negative 2 negative 4t over 1 minus 3t. Cross multiplication, we will have 3 minus 9t equal 4 plus 8t. So we get, right, negative 1 equals 17t, يبقى t equal 17 ts, يبقى t equal negative 1 over 70. Therefore, this is how to solve these kind of questions. Right, again I say this, when a vector is parallel to a vector or in the same direction as a vector, they have the same gradient, and the same gradient means the gradient is j over I equal j. The gradient is j over I of the first vector equal j over I of the second vector. One more thing is, if I have a vector representing velocity, right? Now, the velocity, say, of a vector v, velocity is v equal, for example, 3i plus 4j. Right. We know that the speed is the magnitude of velocity. But speed is the square root of 3 square plus 4 square is 5. If I have a question like this, I say to you that a particle, right, having a velocity in the direction of a vector 3i plus 4j, its speed is 25. Find its vector. It's velocity vector, vector of velocity. Now, we were asked that this particle has a speed 25. Its velocity parallel to the vector, which is right 3i plus 4j, parallel to 3i plus 4j. Okay? Therefore, the velocity vector, the velocity is a multiple of this vector, This vector has a velocity, has a speed equal the square root of 3 squared plus 4 squared equal 5. Our new velocity of magnitude 25. So, how many times 25 over 5 equal 5? Give our new velocity is 5 times a given velocity. Therefore, V equal 5 times 3i plus 4j, which means 15i plus 20j. This is a very important question. So we take another example. Right. A particle having a speed of 39 and it is moving in a direction of a vector 5i plus 12j. So we get the magnitude. What is the magnitude of a vector? Right. Five I plus 12j of the vector 5i plus 12j. The magnitude is the square root of 5 squared plus 12 squared, 13. The 39 is how many times the 13? Is 3 times. Therefore, our velocity is 3 times a vector 5i plus 12j, which means 15i plus 36j. Now we are going to go into how to make use of vectors to understand problem of motion. what we call problems of motion or problem of navigation. What do we mean by this? If a particle is at the position initially at the position, this position initially called R0, and is having a velocity in that direction, v, after a time t, it moved a vector vt. The new vector, the new position vector of its new position, r equal r0 plus vt. R equal r0 plus a movement. The movement is a displacement. Displacement is a product of velocity times time. Just like distance is a speed times time, displacement is velocity times time. This rule is very important, and we can make use of it like this. If we have now a particle, right, starts a particle, it starts at a point 3I plus 7G and moves with constant velocity 2I minus G. Find its position after 4 seconds. We use the rule R equal R0 plus Vt. We are given R0, 3I plus 7G. We are given the velocities, 2I minus G, and the time 4. Therefore, 3I plus 7G plus 8I minus 4G. Therefore, we get 11I plus 3G. This is the new position. Now, we can have a different type of problem. We can have a particle, right, moving with constant velocity, right, is at the point particle initially at 2I minus 4G. Right? 5 seconds later, it is at a point, right, 12I plus 16G. Find its velocity. We are going to use the rule R equal R0 plus Vt. R is 12I plus 16G. R0 is 2I minus 4G plus the velocity V, and the time is 5. We bring this here, we get 10I plus 20G equal 5V. If V equal 2I plus 4G. Good. Another question. It says here at t equals 0, a particle at 4I plus 7j, and is moving with speed 15 in the direction 3I minus 4j. Find its position after 2 seconds. Here we don't know the velocity, but we don't know that the velocity is parallel to 3I minus 4j. 3I minus 4j has magnitude how much? Has magnitude the square root of 3 square plus 4 square equal 5. The 15 is how many times of 5? Is 3 times. This means the velocity is 3 times the given vector 3I minus 4j. Again, our velocity in the direction of 3I minus 4j. Therefore, it is a number times this vector, because it is vector parallel to vector is related to it. A number times it. We get the magnitude of 3I minus 4j, 5. And we want a vector of magnitude 15. 15 is how many times 5? 3 times. But the velocity is 3 times this. Means the velocity is 9I minus 12j. Then we use the rule R equal R0 plus Vt. R0 is 4I plus 7j, plus the velocity is 9I minus 12j, the time is said after 2 seconds. Therefore, 4 plus 18, 22I, and 7 minus 24 minus 17j. 7 minus 7 minus 24 by minus 17j. Now, we have another type of problem, also of problems of this kind. You remember we have this all these previous problems, it's motion with constant velocity. But what about motion with constant acceleration? Motion with constant acceleration. Motion with constant acceleration, then we have the rule V equal U plus AT. But this time we are going to be vectors. V is a vector, U is a vector, A is a vector, T is a scalar. We can have then problem like this. A particle right, has V equal negative 3I plus J at t equals 0, but this is the initial velocity. It moves with an acceleration A, 2I plus 3J. What will be the velocity? What will be the speed after 3 seconds when t equals 3? We get first v equal u plus at. U is the initial velocity. And then this is u minus 3I plus j. Plus the acceleration is 2I plus 3j times the time is 3. Negative 3I plus j plus 6I plus 9j. We get 3I plus 10j. This is the velocity, but what is the speed? The speed is the square root of 3 squared plus 10 squared. And this would be 10.4 meter per second. We can have problems which include force, because force equal ma. We just remember that with a latent force with the acceleration. The questions say this, like a force act on a particle of mass, 2 kilogram, right? F acts for 10 seconds. The particle initially at rest, and 10 seconds later, and after 10 seconds, its velocity equal 10I minus 24j. We say v equal u plus at. Yeah, but 10I minus 24j equals 0 plus the acceleration times the time is 10. Yeah, but acceleration equal I minus 2.4j. This acceleration. The force F equal ma. Therefore, the force F equal, the mass is 2 times I minus 2.4 g. Therefore, the force is 2I minus 4.8 g. Now, we have problems, right? Very, and say, interesting problems, like this question. It says here that at 8 a.m. ship A at RA equal I plus 3J, and ship B at RB equal 5I minus 2J kilometers. Given VA equal 2I minus J and VB equal minus I plus 4J, right? Now it says write down, we wanted to know find R, find at time t RA and RB. For A, RA equal, right, R0 plus VT. R0 for A is I plus 3G plus the velocity VA is given 2I minus J times T. Therefore we got 1 plus 2T I plus 3 minus TJ. For B, RB equal R0, which is 5I minus 2J plus the velocity of B, which is I negative I plus 4J times T. Therefore equal to 5 minus Ti plus negative 2 plus 4TJ. It is, we asked to find a vector AB. AB is OB minus OA, means RB minus RA. We subtract vector B minus vector A. When we subtract the vectors, we do this. We subtract the I minus I. When we subtract the I minus I, we subtract the number minus the number, then the T minus the T. Number 5 minus 1, 4. Then the T. Minus T, minus 2T, minus 3T. I plus the J's. Minus 2 minus 3 is negative 5. 4T minus T plus 5TJ. This is the vector AB. This is called the position of B relative to A. Relative to A. It's saying in the question that show that the two ships don't collide. To show they don't collide, what we do is to collide if they collide, or if collision takes place, then the vector AB should be 0. So we equate 4 minus 3T equals 0. We get T equal 4 over 3. We equate negative 5 plus 5T equals 0. We get T equal 1. They are not equal. Not equal. Therefore, they don't collide. Also, there is another way to show that they don't collide. We equate, we say vector RA equal vector RB. Vector RA equal vector RB, we equate the I with the I, and we find T. And we equate the J with the J, we find T. we find the values of TT are different. There are two ways then. Either we do it without getting the vector AB, or we do it with getting the vector AB. Without getting the vector AB, we say, will they collide? Will RA equal RB? So equate the I with the I, and we find T. The J with the J, and we find T. We found it different. Here we have the vector AB. If they collide, then the vector is 0. So we put this equal 0, we get the value of T. We put this equal 0, we get different value for T, therefore they don't collide. It says here that find the distance between them at 10 a.m. At 10 a.m. means T equal 2. Because T equals 0, it is 8 a.m. Yeah, but 10 a.m. means T equal 2. At T equal 2, we get the vector AB. We will get the vector AB at T equals 2. We had the vector, this vector, and we substitute T equal 2. Therefore, we get 4 minus 3 times 2 I plus negative 5 plus 5 times 2 J. Therefore, we get negative 2I plus 5J. Therefore, the distance AB, not the magnitude, the distance, is the square root of 2 square plus 5 square under the root. And we calculate this. The square root of 29. We get the square root of 29, root 29, and we get the answer, which is 5.3, let's say 5.4 kilometer. Two significant figure. This is the idea of this topic. The idea of the topic is that we will be given two particles moving. We will write R and two particles A and B. We will write R equal R0 plus VT. For A, we get RA and we get RB. And then we will get questions about them. They say to us, maybe show that they collide. We equate RA RB. How? We take the I part here, equate it with the I part there, and we find T. We take the J part here and J part here, equate it, we get T. If we get the same T, mean they collide. If we don't get the same T, mean they don't collide. If we were asked to find the vector AB, then we subtract RB minus RA. Sometimes we ask questions that when will the particle, say B, is north of A? B is north of A means the position vector of A and B, they have the same I, the same amount of I. If by A and B, they have the same I, value of I. If they say that B east of A, then B is east of A, then A and B, they have the same J. If they say B is north east of A, like this. B is northeast of A. This means that distance equals that distance. This means that the vector AB, the I and the J's parts equal. This is the kind of questions you will get. And this is the end of the topic.